Welcome friends. Today we will make a free energy generation using a photodrum, having in a mind that you can utilize sunlight to produce a free energy. In this video we have used a photodrum and a copper coil and magnets to generate a free energy. In future we may see that we can use this photoelectric effect and generate a free energy. So for this we will take a photodrum and using this photodrum, it's a photodrum which I have taken from a cartridge of a Xerox machine. We can use it for the generation of electricity with the help of copper coil and magnets and see that what happens, how the output comes. So I have taken an insulated copper wire. So this type of insulated copper wire will take, and I wound this insulated copper wire over the photodrum and do the connectivity. So I'll take the photodrum which is removed from the cartridge. Now I'll make a point, 2 points using a tape. I'll both side tape, so that I'll make a 2 points. In between that I'll rotate maximum number of coil turns, insulated copper wire turns. So 2 points, we will cut it with a scissor, and we will make 2 points. In between that we can rotate a maximum number of coils. So we have make 2 points like this, so that we can rotate a maximum number of coil turns, so that maximum flux linking the coil may change and maximum EMF may be generated. So we will use this photodrum in consideration that in future photoelectric may also may help in generation of electricity. So I have taken 2 points is made. Now we will take an insulated copper wire and make a solenoid or a coil over it with a maximum number of turns. So few length is left over in order to solder a filter capacitor and a diode for rectification, half wave rectification to get a pure output of DC. So length of copper coil is left. After that we will rotate maximum number of turns as much as possible over this photo drum. So one by one tightly you have to rotate maximum number of turns over this photo drum. See that no gap is maintained between the coil and maximum number of turns. One by one we will rotate it over the photo drum. So we are making a coil so that it is tightly held without a remotion. So maximum coverage we have done of rotation. See that 50 to 100 and above turns we will make to make a proper solenoid, and maximum flux will be linking with the coil. So maximum turns we are making so that maximum flux may link with the coil. So this also works on the principle of Faraday's law of electromagnetic induction, stating that whenever a flux linking the coil changes, EMF is generated on the basis of that. And we see that photodrum may help in generation of more electricity in future. So we are doing using a photodrum. After completing a maximum number of turns, we see that the end point is tightly fixed over the cylindrical photodrum. Once it is been done, the end of this coil with the same length which we have started in initial turn, the leftover length of the coil, same length, we will cut it with a scissor. Once it is been done, tightly holding it, we will cut it with a scissor, leaving the same length as the initial length of the coil while we started the winding. So same length we will take and cut it with a scissor. Once it is been done, straighten the wire. Remove the insulation with a knife or a blade so that a proper solder can be done. We will remove the insulation with a knife or a blade so that a proper insulation and solder can be done over this copper wire. Proper conductivity will take place. Whatever the EMF is generated into the coil can be removed from this point. Once it has been done, next we will take solder it properly. See that dry solder may not happen. Properly solder it using solder plugs and all. Once the solder is been completed, next we will take a wooden stand to mount this so we will take a wooden stand like this and we will mount this photodrum over it. See that it is properly mounted in order to see that a maximum flux will be linking with the coil when the magnet rotates in front of the coil. So we will make such arrangement that the coil will be in front of the motor. We will fix it properly. We will take a two-way stick tape and cut it according to the length of the wooden board. We will stick this two-way tape over the wooden board. With the screw, we will tighten the board over the plywood board. With the screw, we will tighten it into the plywood board so that it should not shake. So we have tightened it properly. Next we will remove the sticker over the two-sided tape and fix this arrangement over the tape so that it will be in the front side of the wooden stand. Once it has been fixed, Next we will take a motor, DC motor, to mount it in front of a coil with a magnet in front of the motor. So we will fix this motor in front of the coil so that a maximum when the magnet rotates, maximum flux will be linking with the coil. With the screw we will fit this DC motor in front of the coil. We will tighten the wooden board so as see that the magnet is in front of the coil. Tighten the screw of the wooden board. So we have tightened the board strongly, so the motor is fixed without shaking. Once it has been fixed, see that maximum flux is linking with the coil and magnet is nearer to that coil. So all the arrangement is been done. And now the time is to solder the wire of output wire properly with the filter capacitor and forward bias diode. So we will take a diode and see that half wave rectification will happen whenever the EMF is generated in the coil. So we will take a diode and make a half wave rectification. So we have taken a filter capacitor and also a diode here. So this is a filter capacitor. So filter capacitor is used in order to filter out the residual AC which is generated in the coil. So whenever the magnet rotates in front of the coil, EMF is generated. So this EMF is in the form of alternating current, that is AC. So we have to convert this AC into DC direct current. So for that we will use a half wave rectification method by using one diode in a forward bias and a filter capacitor in order to remove the residual AC which is present in the coil. So we get AC alternating current in the coil. We will convert it into a DC with the help of a rectification diode, and filter capacitor removes the residual AC. So now we are soldering a diode with the output in a forward bias. So once the diode is been fixed, now next step is to fix the filter capacitor which is parallel to the coil. Diode is fixed in a forward bias with one output of the coil, and capacitor is connected parallel to the diode and the coil. So in order to remove the residual AC with the two coils, it is connected in parallel. Next we will connect the filter capacitor with the outputs of the coil in parallel state. So both ends of the capacitor are connected. See that the positive point is connected to the forward bias of the diode, and the negative point of the capacitor is connected to the another output of the coil. So once it is been connected properly, our circuit is completed. See that a proper soldering is been done. No dry solder has to be done, otherwise a leakage may happen. So see that proper soldering is been done. So here proper solder is been done. DAD is in a forward bias with one point and capacitor is in a parallel connection to filter out the residual AC. Once it has been done, now we will take an extension board and connect it with the output of the coil in with the capacitor and diode. We will take a tape and fix the extension board to the bottom so that it will not shake. Once it has been done, this is the time to solder the output of the coil to the extension board. See that proper soldering is been done. No dry solder has to be done so that maximum output will come to the extension board. Now the solder we have connected the extension board with the output with the filter capacitor and a power bias diode so that we can get a pure DC in the output in the extension board. Our circuit is totally completed. Now it's the time to give the torque to the motor and see that EMF will generate in the coil or not. So the coil is kept very near to the magnet and make it flexible so that the flywheel will rotate in front of a motor with the magnet. Now we are fixing the output input to the motor through the extension board and give a torque and see that EMF is generated or not. So by giving a torque, slowly insert the terminals of the motor inside the extension board and see that coil is very near so that maximum flux will link with the coil. So we are bringing the coil in front of the motor and give the torque so that so the motor started rotating but it stopped. Again we will give a torque and put it very near. The coil should be very near so that a maximum flux will link with the coil. So we give a torque and see that EMF is generated in the coil. So once the EMF is generated in the coil, the EMF is in the form of continuous current, which is converted into DC in the form of DAD and the capacitor. Now we have to connect the bulb and see that output is coming on. So the bulb is show that maximum EMF is generated in the coil. So this works on the principle of Faraday's law of electromagnetic induction, stating that whenever flux linkage with the coil changes, EMF is generated. So the magnetic flux in the coil changes in the coil in the form of you can convert DC after the condition full electrification or electrification the capacity in order to reduce the residual AC. So here you can see the voltage is here and we will connect it with the extension board and see the and generating the phase EMF. Here we have taken a photodrum to see that in future we can generate free energy using photoelectric effect also an experiment. Thank you friends. please subscribe the channel and press bell icon. Whenever I create a such type of video, you will get the notification. So you can see here the bulb is glowing brightly and efficiently. Thank you friends. Please subscribe and press the bell icon.